So, first we start off with the molecule C2H6, and C2H6 is a covalent molecule, meaning that each of the atoms in the molecule is joined together by a covalent bond, which is the sharing of electrons. Okay, and C2H6 is commonly known by its name ethane. So ethane is C2H6's common name. So to start building the Lewis dot structure, we have these building blocks, and here we have our 2 carbon, which is our C2 in C2H6, and we have our 6 hydrogen, which is our H6 in C2H6. So to start off building this, we're going to put our carbon together, and these will go in the middle because there's only 2 of them, and they are most reactive because they have 4 bonding points. So carbon's going to go in the middle, and we're going to then take our hydrogen and make bonds with the other electrons to make complete bonds, which would be 2 atoms together. So complete bond would look like this with 2 atoms. So we're going to do this 6 times with each hydrogen. So we filled in all the empty spots and completed the bonds, and we have 1, 2, 3, 4, 5, 6, 7 complete bonds. And there's a way you can check this. So you count up all the electrons there are, so we'd have 2, 4, 6, 8, 10, 12, 14 electrons. We have 14 electrons. You then divide this number by 2, which would give us 7, and you would take any unshared pairs there are, which in this case there are 0 unshared pairs, and you would subtract the number of unshared pairs, and the number you get out should equal the number of bonds there should be. So in this case there should be 7 bonds, which there are in fact 7 bonds here. 5, 6, 7. So to finish writing this, you would show the formula is this, with 2 C's in the middle, and then our 6 hydrogens on the outside, and then 7 bonds, which are represented as lines to show the bonds between the hydrogen and the carbon. So this is how you would write the finished C2H6 molecule, Lewis dot structure. So next we have another molecule, and this molecule is called a polyatomic ion. But in this case, since it's a negative ion, this would be instead a polyatomic anion, representing the negative in the molecule. And this molecule has both iodine and oxygen in it, and this is commonly referred to as iodate for its common name. So for this molecule iodate, we'd first start off with iodine, which is in group 17 of the periodic table, so it has 7 valence electrons. And then we would have our 3 oxygens, which are in group 16 of the periodic table, so it each have 6 valence electrons. So, we're trying to do this together. First we put iodine in the middle, but then when we try to do it, we see that it doesn't quite bond the same way like C2H6 did. I mean, where would this go? Would this go just right here, and this go right here? No. This is a little bit different. So to make this work, we'd actually do something called double bonding, where we would actually take the oxygen here, and we would move this electron and put it here and have it double bond with this electron pair here. And we would do the same thing with this oxygen molecule here, where we would take it and we would take this electron and have it double pair with this electron pair over here. But for this one, we would move we would move this one over here and have it pair with this unbonded electron to create an electron pair. But the thing is, in order to complete this, we would have to add another electron right here, and to do this we would have to draw another electron and signify this electron as different from the rest. So one way you could do this is perhaps drawing an X through it, or a circle, or whatever. Just make sure that it shows that it's different and that it was added on to this in order to make this whole molecule stable. But by doing this, you would make this a negative polyatomic ion, which, because the extra negative charge from the added electron would overall make the charge different, and in this case negative, creating the polyatomic anion. So to draw this out, we would have our iodine in the middle, and then our 3 oxygens. And to draw out the double bonds, we do 2 lines, and the single bond would just be 1 line, and then we draw in the other electrons. Whoops. And remember, you have to signify this one as different by somehow, and the way I'm doing is by drawing a little red X through it. So you have to signify this one as a added electron, showing that this is now a negative ion, an anion. And the way you'd finish this is by putting it in brackets and putting a negative sign on the outside to show that it is a negative polyatomic anion. And this is how you would show the Lewis dot structure for an iodate and for a negative polyatomic ion or a polyatomic anion.